An atom has positive protons, negative electrons, and neutral neutrons. Each of these pieces is called a particle. And when we talk about electricity, we're talking about positives and negatives. We're talking about particles. Particle physics has four fundamental forces. Electricity belongs to the fundamental force of electromagnetics. At this point, we've looked at the atom and seen that it has negative electrons, positive protons, and neutral neutrons. The main stars of electricity are the electrons and the protons. The proton is 2,000 times larger than an electron, and it is positive and it's in the nucleus. The electron is tiny and it's on the outer orbits of the atom. 2,000 times difference in mass. But if you look at the magnitude of the charge, the plus and the minus, they are equivalent, they are equal. So from here forward, we're going to call the proton the plus and the electron minus. An atom will be represented like this: a plus and a minus. This right here would be neutral. This would be just a proton, and this would be an electron. The plus and the minus, the proton and the neutron and the electron, are called charged particles. The study of electricity is about the study of moving charged particles. Whether it's a plus or a minus, a proton or electron, if it is moving, you have electricity. Now, because protons are so large, they rarely move in solids. So usually when we talk about electricity, it's the electron that is moving and the proton stays still. Another type of electricity is called static electricity. And this is the buildup of charged particles on the surface of something. So let's say, for example, a balloon. If you rub a balloon on hair or some type of wool, it will build up negative particles on its surface. This buildup of negatives on the surface is called static electricity. The word static means stationary. So here we have a giant negative charge building on this balloon, and the negative charge is going to want to find a positive charge to find equilibrium. Negatives and positives are always trying to find equilibrium. Pluses are looking for minuses. So they are attracted to each other. The plus and the minus will come together. On the other hand, minuses and minuses, two electrons, are repelled from each other, and two protons are repelled from each other. So if you had a box, for example, and you put 4 electrons in it, they would spread out as far as they could in this box. Same if you put 4 protons. If protons could move. If you put 4 protons and 4 electrons, they would come together and the box would be neutral. So this is the forces that these charges will place on each other, and they do that through what is called an electric field. So every charged particle gives off an electric field. An electric field is very difficult to explain. It's not a force unless there's another charged particle in it. So this is a negative charged particle right here. If you put a positive particle here, this negative is going to exert an attractive force on the charged particle. This is a positive particle. Now it has an electric field, but that electric field does nothing until there's a negative charge within it. Once there's a negative charge within it, it will attract the negative charge. This force on the negative charge is coming from this positive charge, and this force on the positive charge is coming from this negative charge. But there's always a field around these particles. Now one thing you might want to notice about these fields is that a positive charge has a field radiating and it's going out. Radiating means it goes around. And this, notice each line is going out. Whereas a negative field is coming into the negative charged particle, the electron. So this is what the fields will look like. The positive particle has a field radiating out, and the negative is radiating in. Two positives, on the other hand, repel each other, so they would go out and they're repelling. In the end, the forces that these particles place on each other look like this. And these are the fundamental rules that you want to remember as we go through this. Positives repel, two negatives repel, and a positive and negative attract. One thing that's very important about charge is that it's conserved. So you can never destroy a negative and a positive charge. Now they can transfer. It might seem like they disappeared. So this negative electron might transfer, and it would look like you got rid of this negative electron. But within the entire system, which would contain both these objects, you still have not destroyed it. So charge can neither be created nor destroyed, but it can transfer. Let's take a closer look at an electric field. If I place this positive here, you can see the electric field around this positive particle, which would be a proton, is radiating out. If I place an electron over here, they're radiating in. So the two fields are creating an electric field, and these are what the field lines will look like. Now this sensor right here is a positive charge. If I place it here, you'll see an arrow coming out of it. That's what we call a vector. And the length of the vector is showing the magnitude of the force being placed on it, as though it's being pushed. And you can see it grows and gets smaller, and it also has direction. So right here is a very strong place for the field, and it's directing straight across. So because it's a positive, this is positive, this positive is pushing on it right here. It's pushing on it, and it's creating an incredibly strong force on it. And now the negative one is pulling on it, and so it's pulling it this way, also helping to create that force. The farther you get away from the charge, the weaker the field. So if I go down here, notice how short the arrow is now. The field is has less strength down here, so it's much shorter of an arrow. The force being placed on it's much smaller. Now this electric field is not quite the same as a magnetic field. They are slightly different, but they act very similar. So this is an electric field. So to review, electricity is the flow or movement of electric charge. Because protons usually don't move, it's for the most part the movement of electrons. Static electricity, on the other hand, is the buildup of charge, and that buildup will cause various phenomena like lightning. Charged particles have an electric field around them. When you place another charged particle in that field, it will exert a force on that particle. Those forces are summarized in this chart. Opposites attract and like charges repel.